Okay, here we go. We're going to solve a polynomial inequality, and we're going to do it two ways. One through graphing and then one algebraically. So what do we got? If we read it out in words, it really helps. So it says x squared is less than or equal to x plus 6, and we have to solve. So what that means is we have to solve for the x values that make this thing true. Truly, it means this function being less than this function. So if we draw them both, each function, we just want to know the x values where this one lies underneath this one. So I'm going to draw x squared. Just do a basic sketch. We know x squared looks something like that. And then I'm going to draw y equals x plus 6. So I'll call 6 there, so negative 6 there, and x plus 6 just looks like this. Something like that. It's a line, right? Going through the y-intercept of 6. So we want the parabola to be less than or equal to x plus 6, to be less than or equal to the line. So that's whenever the curve falls underneath the line. So the solutions are actually from this x value to wherever they intersect here, this x value, because you can see all of this area here, the curve is underneath the line. So you could solve using a system of equations and solve for the places where they intersect and figure that out if you know how to draw them. But we're not always going to know how to draw every single inequality. So instead I would recommend doing it algebraically, where we can compare it to 0. So I'm going to treat this kind of like an equal sign for the algebra and move everything over to one side. So I'm going to say this is x squared minus x minus 6 is less than or equal to, if I brought those over, I've now left 0 on the right side, less than 0. So now we're just trying to say this parabola is less than or equal to 0. Well, I know I can factor. This is x minus 3 and x plus 2 is less than or equal to 0. The reason I want to factor, if we were solving for where it's equal to 0, it would be really easy. We would see it's 3 and negative 2. But we don't want just where it's equal to 0. We want to know all of the x values where it's less than or equal to 0. So I'm going to start at those points. X equals 3 and x equals negative 2 makes this thing 0. I'm going to plot those on a number line. So negative 2 and 3. And I know at those points this function is 0. Now I'm just going to test every gap in the number line, plug it back in here and say, is it less than 0? In other words, is it negative or is it positive? So I'll show you what I mean. I'm going to start over here on the right side. So I'm going to plug in something greater than 3. Let's say 10. So if I plug in 10 for x, I get 7 times 12, which is positive. We don't even care what the value is. We just know it's greater than 0. If I plug in something in between these two, let's say 0 for x, I'll get negative 3 times positive 2, which is a negative. Negative times a positive is a negative. So that's negative. And if I plug in negative, say negative 10, I get a negative times a negative, which is a positive. Now we go back to the sign and say, well, we wanted all the values where it's less than or equal to 0. So those are all the negative values, or where it's equal to 0. So you can see it's this interval right here, anywhere from negative 2 to 3. So if we were to write this in interval notation, it's square bracket negative 2, square bracket around a 3. And that's the solution to this inequality. It's not just one x value like we're used to with regular equations. It's an interval across the x-axis where it makes this inequality true. So hopefully that was helpful. Move everything to one side, compare it to 0, find the values that make it 0, and then test intervals, the intervals around those values to determine whether your equation becomes positive or negative. You can always send us more questions to info@arnoldtutoring.com. Thanks.